All right, this is Mr. Gilliam, and today we're going to start using variables with our word problems. And so I have some word problems here today that I want to help solve. And I drew little pictures already on the slides, but if you could draw those pictures as well, that'd be, I think it'll help to figure out some of these problems. The question reads, a new hotel was built with R rooms. So this is a variable right here. I'm going to underline R rooms. The first weekend it was open, 2/3 of them were reserved. Which of the following expressions represents the number of rooms which were reserved? Well, because we're just starting to introduce variables and word problems, let's just pretend that R really was a number, because after all, variables do represent numbers. So let's just pretend that R was 9. So let's just say the problem says a new hotel was built with 9 rooms the first weekend it was open. 2/3 of them were reserved. And so if I change the variable to an actual number, like 9, I could divide it into thirds. And I would know that 2 of the thirds would represent the number of rooms reserved. So in this case, 6 of the 9 rooms would be reserved. However, there's not very many hotels with 9 rooms. In fact, there's a lot of hotels that have a different number of rooms. And so that's why we're going to use variable to represent that, because we could be talking about a lot of different new hotels, and not all of them will have the same number of rooms, but if we can come up with some sort of an expression to represent 2/3 of them being reserved, no matter how many there are, then that would be beneficial to us. So when I think of 2/3 of 9, I think of, okay, 2/3 of the rooms are booked. Or when I think of 2/3 of 9, when I'm trying to find an amount of something, I know that that of means to multiply. And so just to check my work here, it looks to me like there would be 6 rooms available if R equaled 9. And I can count 1, 2, 3, 4, 5, 6 as well. And so I think that instead of 9, because this is what we used for R, we could do 2/3 times R, or R times 2/3. Okay? And so one of the strategies I like to use on these is putting a real number in that would make it would make sense, and the numbers would work out well, and then trying to solve the problem with a real number, and then deciding what operations I use to actually solve the problem. And then that would be where my variable expression came in. Until we get good with the variables, I think that imagining them as real numbers might be helpful. So let's take a look at another problem. And in this problem, again, I've drawn a little sketch here to save myself time for the video. But it says that Paula bought P packages of 6 rolls of tape. Okay, so P packages. So there's my variable this time. And in each package, it says there were 6 rolls of tape. So then she bought 4 individual rolls of tape. How many rolls of tape did Paula buy? Okay, well, in this case, I'm just gonna change P to 2, and let's just try to solve this problem if P was actually a number like 2. And so it says if she bought 2 packages of 6 rolls, I have 6 rolls in each of these packages here, and then she bought 4 individual rolls, 1, 2, 3, 4. How many rolls did she buy? Well, we would add 6 plus 6 plus 1, 2, 3, 4, right? Because we want to know how many total rolls she bought. So we do 6 plus 6 plus 4. Or we could do 2 times 6 plus 4. Okay, we have 2 packages, and there are 6 rolls in each one, and then we're going to add 4 individuals on the end. So in this case, we decided that 2 was our variable of P, but instead of using 2, we could use P. So P times 6. And then plus the 4 individuals. So in this case, we would, not that one, that would be subtraction. P times 6 plus 4, D. Okay, and so I really think that to begin, it might be helpful for you to think of a real number and try to solve the problem, and then think about what operations you're using. So we could be doing 6 plus 6 plus 4, or really what we're doing is 2 times 6 plus 4. And 2 is represented by P this time. In this case, it says that Lisa is traveling down the highway at 40 miles per hour. Which expression shows the distance she will have traveled after 8 hours? So let's just pretend we wanted to know how many, here's the variable here that we need to worry about. Let's just pretend that she was driving for 3 hours. and try to figure out the problem that way. So after 1 hour, we know she would have gone 40 miles because she's going 40 miles for every hour. And then after 2, she would be at 80. And after 3, she would be at 120. So let's think about this. I could figure out how many miles she's gone after 3 hours. But what's the relationship here between the 1 and the 40, the 2 and the 80, and the 3 and the 120? Well, to Mr. Gillum, I see a pattern here that we're multiplying by 40, multiplying by 40, multiplying it by 40, and we're getting to the next number. So that's what I'm going to do. I would take, in this case, to figure out for 3 hours, I would take 3 times 40. And so in this case, when 3 is really h, I'm going to take h times 40, or 40 times h. So in this case, we're going to say D, 40 times h. Whatever hours we decide, we can always multiply it by 40 and figure out how many miles we've gone. All right. In this case, it says that Frank had B bottles of water, so we don't know how many bottles of water Frank had, before his friends came over. His friends drank 9 of the bottles. After his friends left, Frank went to the store and bought 12 bottles, which expression shows how many bottles of water Frank has currently. So again, because we're still learning with variables, and maybe a lot of us can already do this mental math, but let's just pretend that he has 12 bottles to start with. Or better yet, let's pretend 13 so we don't get the 12s mixed up. I'm going to draw another bottle on here. So there should be 13 bottles. Okay, we're going to say there's 13 bottles. Okay, and it says that after his friends came over, they drank 9 of them. So he started with 13 and they drank 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now as I'm crossing them out, that's a form of subtraction. So I'm going to say we're doing 13 and we're subtracting 9 of them. But then Frank went to the store and bought 12 bottles of water. So then, okay, he bought 12 more. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. These are the shorter, stouter type of bottles, apparently. Anyway, he added 12 onto the number that he had remaining. So then he added 12. Okay, so he started with this number, 13, but really we don't know how many he started with, so we'll pretend he's B, we're not sure. And then we're subtracting 9 and adding 12. And that'll be the number of bottles that he now has. So in this case, we'll say that D would be the expression that we're looking for. All right, this problem has some percents, and so we need to take a little bit of notes on percent real quick. So the price of a new computer is $P. So I'm going to circle that variable there. It says the computer is on sale for 60% off. Which expression shows the savings that are being offered on the computer? Okay, let's think about it this way. Percent is either a 0% up to 100%. Okay, this would be like paying nothing. And this would be paying full price. And so some of you probably have gone shopping and seen like 50% off, and you know that it's half as much money as whatever the price says on it. 100% of the asking price would be paying the whole thing. Paying 0% would be like paying nothing. So 60 is somewhere in the middle. So if I had this from 0 to 100, and 60, let's say that's 50 right there, we are looking at 60 and we're looking at 40. Okay. In fact, I'm going to label this all the way down to 20, 10, 70, 80, 90, and 100. So if I'm paying full price, I would be paying way up here at 100%. But in this problem, let's just pretend it's $100. So each dollar would represent 1%. In this case, this computer is on sale for 60% off. So I can actually take away 10, 20, 30, 40, 50, 60%. I don't have to pay 100%. I just have to pay 40% of the actual asking price. And so if I need to pay 40% of the price, in this case, I would be looking at B. I'm thinking 40% of, that's a keyword meaning multiply, 100. Or in this case, 40% of P, whatever the price actually is. And so you're probably aware that not all computers cost the same amount of money. So being able to use a variable as in our expression, it gives us the opportunity to change the price of the computer and figure out different things. So it's a way to write an expression that can be useful in more than one way. So in this case, it's on sale for 60% off. So the amount, I guess I should answer the question. It says, which expression shows the savings that are being offered on the computer? So unfortunately, I just answered the question incorrectly. This would be the amount paid, which doesn't answer the question. So here's a learning opportunity, learning moment for you. The amount paid was 40%, so it would be 40% of the asking price, which would be B. Unfortunately, it asks us the savings that are being offered. So how much money are we saving? Well, we're saving the green lines here. We're saving this 60%. So instead of 0.4 times P, it wants to know how much we're saving. That would be 0.6 times P. That's how much we're saving. So I apologize that I began by making a boo-boo on that one. So make sure, even Mr. Gillum, you got to read the question very carefully. Okay, it asks us the savings that are being offered, and so the amount saved is 60%. I guess the last thing I should say about percent is 60% would be represented by the decimal 0.60. 50% would be represented by 0.50. 40%, 0.40. When we're using calculations, we don't push a percent button in our calculator. I mean, you can, but we use the decimal version. And the decimal version of a percent, because it's out of 100, we just divide whatever the percent is by 100. So 60 divided by 100 actually equals 0.60. So that's where this number comes from, because a percent is a whole would be 100%. So we divide the percent by a whole, and that tells us what decimal to put in there. All right. We have another one here that says the price of a new computer is P dollars. So again, we have this variable P. It says that the computer is on sale for 30% off, which expression shows the savings, okay, being offered on the computer. So again, Mr. Gillum's going to think of it this way. He's going to think, okay, 100% is full price, 0% is zero price. I'm thinking in my head, I am looking for the amount being saved. So in this case, 90, 80, 70, boom, boom, boom. I'm paying 70% of the price. I'm paying this much, but it's asking me how much am I saving? What are the savings? Which is this much. And so 30% is represented as the decimal 0.30, or known as 0.3. So in this case, I need to know if I'm finding 30% of this P. We don't know how much the price is, but I'm trying to find 30% of P, the price we don't know. That represents the amount of savings. So again, we have multiplication problem, D. All right, if you need a little help on the percent problems, I'm not sure how much you talked about percent in 6th grade, so if we need a little refresher on percentages, then I can do that for you. But we're going to try some steady Allen tomorrow and see how it goes. All right, so that's it for today.